Hi, my name is David, and this is my project called Kayia. It starts off with a spreadsheet, and it looks like just like any other spreadsheet. You can do formatting, have expressions, has infinite rows and columns, and the functions are actually written in JavaScript. But it's a lot more. In fact, it's called a deck, not a reason for that, and that it's an interface to a database. So if you notice, one of the differences between a normal spreadsheet, up in the upper left, there's a 6-digit user project space, and this is unique per user. And so then if you can look at someone else's public data by using their user space. And then another thing you might find different from a spreadsheet is, instead of the function symbol, you find a hash mark, and that's because this is the query prompt, and everything in Kayia is a query, the result of a query. Type in X, then it looks and finds what's the value for X. If there's nothing there, you can create it just by starting to use it and put in a value in A1, for example. And by putting in a value in A1, what this says is that's the default row and default column. And so you've just created a scalar value, just straight a string hello, X equals hello is the equivalent. Fill out more, A2, A3, you're creating an array. The default column stays the same of A, so you don't have to specify a column, but you would still have to specify an index. Which part of A do you want? The first, second, third? That's how you would create an array. To create an object, a structure, you would go horizontally across. So here we fill out B and C, and now you can access it by saying x dot b to get 45, x dot c to get. First, we want to change that to reflect what it is, so then we rename it. And actually, we're not renaming, we're adding a name to the column. So here, name, age, and city are additionally placed on top of A, B, and C. You wouldn't find them further on. So for example, if we name the next column, the column D, if we name that to be Z, then if you went down to X, you would see X, Y, and then AA directly, because it's taken that column and put it over here. Same with city, age, everything. Still access it with A, B, and C, but it makes more sense to use name, age, and city. And so now we're looking at a list of objects, and this is like a table. You can access the second row for get that record and makes. There's a new language I'm introducing here, and it's a little bit like SQL. Kayia is a declarative language, but it's using more operators. So first you'll see it'll be selection, something like X, colon filter, so X colon age greater than 100 or age greater than 20, and then semicolon order by, and some of these statements. So the main thing here is to note that it's now changed to an operator, and the reason for that is that you can do more things with it later. I won't get into it right now. Going through these slides fairly quickly. Here's a couple examples of weird, strange things you can do with it. I'll just mention the second one, which is that if you type in colon David and don't specify anything, it's going to go through all tables in the user space and return every row and column where that exact value was found. And it does that very quickly, so interesting. Queries are handled, it's a service, a RESTful service, this database. So you basically query it using, here the default server is on kayia.org, and so you put your user space in and then put the query X. If it was just the A1 value of hello, then that would be what would be returned in JSON. If you had more, let's say you had a table, and in the second row you had just age, the column age filled out, then it would return a structure like this. You just ignore the IDs of 32, 33. But note that it is not like standard JSON where the labels are reproduced every time. Here, 110 is declared as age, and then it's used from then on out to represent age throughout the JSON. So when you've selected a value in the data editor, there's something that happens. On the left-hand side is your standard spreadsheet, but on the right-hand side, you see a smaller spreadsheet and a property box below. That property box, we'll go through it now. You can have lots of different attributes on the formatting of the spreadsheet, attributes on any graphs you have in the spreadsheet. But if in this particular selection you have system attributes, and there are things like the return type, the MIME return type, and then instead of normal types, you have something called expected and constraint. Expected is what it's going to prompt you for, and what's expected of that cell. So, and then constraint is a harder constraint. Can't think of a better word to say. For example, a great example here is to say the expected are all countries that exist, and so that's what you would be prompted for. For example, it would expect to prompt you for, and then constraint is any country. So here are some types. I'm not going to spend any time on this slide, just to show that the types aren't the standard types you'd normally be presented with. For example, age, you might say, is a natural number. It's greater than 18 is the expected value, and then constraint is 0 to 150. So you can see how the constraint's very hard and the expected is softer. And you can set errors based on that to say, I'll allow you if it's 17 to put it in, but constraint won't allow you to put it in at all if you violate the constraint. Okay, now if we go above that, you'll see that when you select, say here, country and the row 3, you have the spreadsheet above. That child deck, it's called, it represents just the value that you've selected on the left. So here again, country 3, the value is the selection of USA as the country. And now you can modify that. It's because this is just another value, you can do a lot of different. For example, if you have, here we have a list of countries, and suddenly you have two capitals for a country. France just has Paris, but Bolivia has both La Paz and Sucre. How do you handle that? Well, you can just go into this child spreadsheet, child deck, and put in both values. It's an array, and you extend it out instantly like that. And you can go further and expand it out as an object to say, okay, La Paz is administrative, Sucre is the capital type is constitutional. So let's look at how we can query for that below. You say country Bolivia, capital city Sucre, and then dot type. So you see how it goes down each level and returns what you want. And this is true if you control click, for example, on the child spreadsheet, it moves that whole thing from the right over to the left, and now that's the main worksheet that you're working with. That's the main deck you're working with, is that one before it was just one cell, and now it's a whole worksheet. And then you can select a value and further go down if you want to break out for example, constitutional to be more information on an array. It's not just constitutional, it's the functional capital. You can do that here. So you can see further and further. And another interesting aspect of this is that you also have the references that are directionally agnostic, meaning that when you have a country and you put in a reference to the capital is then considered on its own and will have a reference back to the country. So a way to explain this is down below in these queries, where you have country is France, and then dot capital dot city, that would give you Paris. But if you go the other way, capital is Paris, dot country dot name, you get France. So you can navigate it either, and it's not bottom up. It's not actually parent-child or child-parent. It's just their level references. And why this is kind of interesting is because you don't need now to predefine a static model. At least that's my hope. Here you might say player, team, sport, and then find out later, in football you can have a player that's on more than one team. You panic, you have to create a link table, and modify and let the usage drive your model, your data model. So for example, that same example, let's say we have Steven Gerrard on Liverpool LFC on his team, and he's been loaned out to Everton. So suddenly he has a second team. Well, instead of having to create a link table and put in a column on the link table called status if they're a member of the team or if they're just on loan, you can model it just like this. And there's no performance penalty for that. Everything is already many-to-many underneath the covers. Functions and expressions, I won't get into it. This is just that there you can, some of these, you can create a function, and it's kind of interesting. Functions aren't really used with Kayia. There's something that is called actions that are used, so I'm not going to go into it further here. But it is. Now, a quick word about the implementation. I'm trying to keep this short. So it's all done on Node.js as the interpreter with a backend of React, which is a key value store. And it's all done in about 1,000 lines of code. It's pretty small. And it's open source, available. Everything in this has been reduced to a key value pair, just everything. So the code, which I didn't go into, which are actions, the database itself, any graphics, the UI, that's all just tiny key value pairs. And it's also, the database is also insert only. So when you create a value of X as hello, and then change it to howdy, and then delete it, those are 3 different actions, and they're all stored. It just finds out which one is the current value based on it's the most current one. And that has this combination is kind of interesting because it can do this list of things. It can scale horizontally using cloud services. I know it's a lot of buzzwords, and I don't like that, but it seems to me a bit true. So here it is. I'll just go through these. Elastic, you don't have to preset the capacity, it just grows. Synchronization isn't the problem because of insert only. Everything is historized also because it's insert only. The system is entirely asynchronous. That's really interesting from the Node.js evented structure. It uses WebSockets to push back any changes, and yet you still have all the relational structure. You can have ACID transactions. And this, again, doesn't just apply to the database, but it's the code for an application. It's the graphics, the UI. Interesting. So this is my project. I hope you found it interesting.